Hello all. In this session, we are going to discuss about Cosmos SDK. It's like an introduction to Cosmos SDK. So Cosmos SDK is a framework for building application-specific blockchains. So here's the outline. So first we'll be discussing about what is Cosmos SDK. Then we'll be discussing about application-specific blockchains, and then the blockchain architecture. Later we'll be discussing about the main components of Cosmos SDK. First, what is Cosmos SDK? So SDK stands for Software Development Kit. Here, Cosmos SDK, it's an open source framework for building the proof of stake blockchains. So some of the examples for proof of stake blockchains are Cosmos and Osmosis. So the main advantage of this Cosmos SDK is that it is open source and it is built in several modules. So it makes it easier for developers to use those modules and can add their custom modules into this SDK and can use for their application. So here, what are the applications or the blockchains that are built on top of this Cosmos SDK are called as application-specific blockchains. So now, what are application-specific blockchains? So before speaking about application-specific blockchains, generally there are smart contracts. So these smart contracts will run on a single virtual machine. Let's take an example of Ethereum. So on an Ethereum, there can be lot of different applications which are developed by different developers or organizations which will run on top of a single virtual machine on Ethereum. So here in case of Cosmos SDK, application specific blockchain means the only single application will be operated on that particular network. So that's the main advantage. So we'll be discussing about the main advantages of application specific blockchains in the next slide. So here, this is a basic architecture of an application-specific blockchain. We'll be discussing about the common BFT and also what is a state machine in the next slides. So here are the benefits of application-specific blockchains. So the main advantage is we can connect with the consensus algorithm. We can the flexibility. So the application-specific blockchains provide the flexibility to developers to use different consensus algorithms. So in order to use that specific consensus algorithm or consensus engine, so we have the concept of ABCA. So here ABCA stands for Application Blockchain Interface. So using that ABCA, we can interact with any of the consensus algorithm. And the thing is that particular ABCA can be used with any of the programming languages. So that gives developers a flexibility to use different programming languages. And speaking about the performance, so as discussed in the last slide, when it comes to smart contracts, so the smart contracts related to different applications will be running on a same virtual machine. So here, all those applications will compete with each other in case of storage or for computing and all. When it comes to application-specific blockchains, the thing is only single application will be operated on that particular blockchain. So here, there is no need for competing for storage or computation. And next comes the security. So since the Cosmos SDK provides the developers the flexibility to make changes, so here it allows the developers to use different cryptographic algorithms, or they can use the famous cryptography libraries that are available, and they can change the algorithms whenever required. That's the main advantage. And next comes the sovereignty. Speaking about Ethereum-based blockchain or other blockchains, the thing is all the applications will be running on top of single virtual machine. So here the application is separated from the blockchain. So several developers will use the same virtual machine and deploy their applications on that particular virtual machine. So let's say there is a bug in that particular virtual machine, and the developers of any application want that bug to be resolved immediately. So in such a situation, it is under the hand of the blockchain. So the one who is running that blockchain, the Ethereum virtual machine, one who is running, they will have the authority to make that changes. So it is difficult in that case. When it comes to application specific blockchains, since we run the blockchain node, it is in our hands in order to make any changes. Next, we'll be discussing about the blockchain architecture in context of Cosmos SDK. So first comes the state machine. So here state machine can be imagined as an application also. So blockchain is simply a deterministic state machine. So it's a replicated deterministic state machine. So here deterministic state machine means, so whenever let's consider this is one state and this is another state. So whenever we apply certain transactions on that particular state, after applying the transaction we'll get another state, we'll move to another state. So here deterministic means whenever we apply those particular transaction, that particular state machine will always move to the same state. That's what deterministic means in case of blockchain. Next, common BFT. So here, one of the famous consensus mechanism is common BFT. So it is Byzantine fault tolerance engine. So what it does is it helps in consensus and networking. Here consensus means validating that particular transaction and whether verifying that whether the transaction is legit or not, and replicating that transactions throughout different nodes that will be taken care by this common BFT. So here we can see it is responsible for propagating and ordering the transaction. And here common BFT is application agnostic. So application agnostic means common BFT only takes the data in bytes format. So the common BFT doesn't have any knowledge about what the application it is dealing with. So that's what application agnostic means. So here, common BFT algorithm runs with several validators. So we have validators, also called as like nodes, and validators are responsible for adding. So validators will be validating the blocks with their pre-vote and pre-commit, and then they'll propose the blocks. Those blocks will be added into the blockchain. So if we see this image, here we can see there's a state machine and below is consensus and networking, which will be taken care by this common BFT. So the interaction between this application and common BFT is taken care by ABCI, Application Blockchain Interface. So what it does is it is helpful for transferring the messages between the application and common BFT. So here are few messages that ABCA handles. So one is check.tx and then deliver.tx. So what check.tx does is whenever common BFT receive any transaction, so using this check.tx, it will pass that particular message to the application. So application will run basic checks like the fees is enough or not. Some basic checks will be done. Next comes the deliver TX. So deliver TX is that message is invoked when that particular transaction is valid. Then the common BFT will pass that particular transaction to the application. That is the state machine. Next we have begin block and end block messages. So what this begin block and end block messages does is, so let's say we want some part of code or some event to be executed at at the starting and at the ending of the block. So in that situation we can use the concept of begin block and end block messages. So whenever the block is added into the blockchain, immediately a code will be executed. So it is irrespective of the transaction, whether the block is having transactions or it is not having transactions, but the begin block and end block events will be executed. Next comes the main components of the Cosmos SDK. So first comes the base app. So here we have discussed something like ABCI, right? So application blockchain interface. It is used for interaction between application and the consensus mechanism or consensus algorithm. So here in Cosmos SDK we have something called as base app. So that base app will provide a boilerplate implementation of the entire Cosmos SDK application. So on top of that, or we'll be using that particular base app to extend our entire application. We'll be extending our entire application through this base app. Next, multi-store. So here in Cosmos SDK, a key value store is available. So in that store, we'll be storing the data in key value format. So here, as we discussed, in Cosmos SDK, everything is modulated. So each and every module will be having its own multi-store. In order to interact with the store, we use the concept of keepers. So what this keeper does is, it is used for interacting with the stores. And keeper helps in interacting with the stores of other modules also. Next comes the modules. So as discussed, Cosmos SDK's main advantage is it is completely modulated. So there are different modules which are already available in Cosmos SDK which are ready to use. Some of the examples are authorization module, banking module, staking, and slashing modules. Each and every module will have its own use case. There are few modules which are already built, which will be used by the developers in order to develop their specific application. So here authorization module, that is used for managing the accounts, and then banking module, which is used for transferring the tokens. And next comes the staking and slashing. Here staking means if we want to delegate or stake some amount to any validator, so that's dealt by this staking module. And next comes the slashing module. Slashing is the concept which is used for jailing the validators or unjailing the validator based on their activity. These are the modules that are already available. Now let's see how a transaction is validated, or how a transaction will pass through the Cosmos SDK. So first, the transaction is relayed from the Comet BFT engine. So the Comet BFT engine will deliver that particular transaction to the application or the state machine, and it is the responsibility of that particular application in order to route that transaction to the required module. So here, for each and every module, there are several transactions. So whenever there is any transaction, that transaction must be related to some module of the SDK. So here, and based on that particular transaction, it will be routed to the required module. So in that particular module, whatever the thing that is present in that transaction message, that will be processed, and then if everything is valid and legit, then that particular application will return a result to the Comet BFT stating whether it is correct or there is an error. So that's what a high level overview of how a transaction goes through the SDK modules. And whatever the content that is being delivered in this session is reference from the Cosmos SDK official documentation and Comet BFT official documentation. Yeah, that's it for this video.